All right, hello friends. So we're going to talk about some integration by parts examples where the integral cycles back to itself through the formula. So I'm going to show you these two examples. So this is really an extra example video on top of my lesson video. So if you're struggling to understand how to use integration by parts, I strongly recommend that you check out my lesson video. So I'm just going to jump right into this. So for example A, so I've got e to the 4x cosine 3x dx. So the whole thing about this that I talked about in my lesson video is that for both of these, neither one of these are really, neither one of these have a derivative that cycles eventually to a constant. So e to the 4x, if I keep taking derivatives of this, it's just going to stay e to the 4x with some constants. And then this cosine 3x, I can take derivatives of this for forever, and it's just going to be either sine or cosine. So there's not necessarily like a best choice now for u and v. So with that in mind, I'm just going to set my u equal to e to the 4x, and I'm going to set my dv equal to cosine 3x dx. So then my du, so don't forget to use the chain rule, so this will be 4e to the 4x, and my v is going to be 1/3 sine 3x. And I forgot my dx there. Okay, so now I can go ahead and use my integration by parts formula. So in my video, my lesson video, I kind of broke this down. So I've got this integral here equals uv minus the integral of v du. So, okay, the one thing I want to do with this is I just want to remind myself that we're referencing back to this original integral. So what I'm going to do is I'm going to call this integral I, and I will eventually reference back to that. So I want to say that this integral I is going to equal, so uv, which is going to be 1/3 e to the 4x sine 3x minus v du. So that's going to be 4/3 e to the 4x sine 3x dx. Okay. So we look at the integral that we have. I cannot integrate this, so what I'm going to have to do is I'm going to have to do this process again. So my u in this case now, let's call it 4/3 e to the 4x. I'm just going to bring the constant with. You don't have to, but I will this time. Why not? And my dv is going to be sine 3x dx. Therefore, my du is going to be 16/3 e to the 4x. Again, we're using the chain rule here. And v is going to be 1/3, let's see, negative 1/3 cosine 3x. I keep forgetting to write the dx. Okay, so here we go. So let's see, I'll clear a little space. Okay, so now I've got that my integral is 1/3 e to the 4x sine 3x minus, and now I'm going to start my new integral. So this will be uv. So u times v, so that's going to give me a negative times a negative. So this will actually be, let's see, negative 4/9 e to the x cosine 3x minus v du. So minus v, so that's a negative and a negative, so that'll turn into plus v du. So let's see, this will turn into 16/9 e to the 4x cosine 3x dx. Okay, so now I want to make a realization here. So this actually references back to my original integral, and so in case you forgot, so maybe I should have written that out, but my original integral was this, right? So this original integral I now have here. So this is telling me then that I'm eventually going to have to bring this integral over to the other side, and I forgot my parenthesis there. So what I want to do now is I want to rewrite kind of where I'm at so that I can see a really clear game plan of how to move forward. So let me make a little space. Oh, and before I go any farther, this should have been 4x. Sorry, my bad. All right, so when I clear my space, what I'm going to do is I'm just going to restate this entire problem with this negative distributed. So when I distribute it, this will become positive and this will become negative. Okay, so here's now my original integral, right? I distributed the negative, so I did a lot here. And so now I've got this, and I brought this 16 over 9 outside of the integral. So now you'll notice this and this are the same. So what I'm going to do is I'm going to add this 16 over 9, this whole integral. I'm going to add it to both sides. And so I can call this integral, so remember I called this integral I. So a nice shorthand for this is I could just call it plus 16 over 9I. So now I can say that I've got, maybe I'll just do the calculation here, I plus 16 over 9I. So that's really going to be 9 over 9I. So this is going to be 25 over 9I when I add them together. So I have 25 over 9I. Remember, I is the original integral, equals everything that you see here. Okay, so then to finish solving for the integral, so all I have to do then is multiply by the reciprocal. So let's see, maybe I'll do it in the pink color. So I need to multiply everything by 9 over 25. So I'll just write that out so you can just kind of visualize. So this is all multiplied by 9 over 25. And so you can see a few cancellations that I'm going to make. So what's my final answer then? So making a little space, when all is said and done, I'm going to get, this is the answer for I, where I was my original integral that I started with. Okay, so let's keep going. So I strongly recommend, if you are watching this because you're struggling with this, I showed you one, and I think the last one was a little hairy. I think this one's a little more straightforward. I'd strongly recommend that you try this on your own. So pause here, give it a try. The worst that happens is you don't get it right, but if you're trying to understand this, the best way to do that is to actually try it and then watch the explanation. Math is not a spectator sport, so you've really got to get in there and try it to understand it. Hit play when you feel that you are ready. Okay, so we've got the same thing here where my u and my dv, they both just cycle. So I am just going to set my u equal to e to the negative x, and my dv is equal to cosine dx. So that's going to make my v equal to sine x, and my du is going to be negative e to the negative x dx. So make sure that you remembered the negative, because we have to use the chain rule, because this is negative x and not x. Okay, so once again, I'm just going to reference this as I for a moment. So this is going to be I equals, so I've got my uv, so it's e to the negative x sine x minus my v du. So let's see, that'll turn into, well, that'll turn this into a plus sine x dx. So this becomes a plus because my du is negative, so I just flipped it right here, okay? Okay, so now, oh, and this is e to the negative x. Okay, so now I start over, right? So I still can't evaluate this integral. That's why I have to start over. So I'm going to just use my integration by parts again. So I go through the same motions. And okay, so now we need to make a little space. Okay, so now I've got this new integration by parts. So I do uv. So that's going to be negative e to the negative x cosine, oops, and I accidentally put a dx here, cosine x dx, and I forgot my dx here. I'm all over the place. Okay, uv should be this, minus v du. So again, this is negative. Oh, this is negative and this is negative. So these negatives become a positive, so this negative stays. Lots of negatives you got to keep track of with this one. So this will be cosine dx. Okay, yeah, I've got everything. Okay, so now this right here, this is my I. So what I can do now is I can add this to both sides, add this integral. So I'm just going to use I as a shorthand for it. So what does that leave me with? Let me make some space. Okay, So now I'm left with 2i equals what you see here. And I think I wrote, gosh, why am I writing dx everywhere? I'm like losing it here. Okay, sorry, there was no dx here either. My bad. Okay, so here we are. And so then just to finish this, so my answer here is going to be e to the negative x sine x minus e to the negative x cosine x, all of this over 2. And so that's it for that one. So that's the final answer. Okay, so hopefully that kind of helps sort out how to use that particular technique and you kind of understand a little bit better of when to use it. I will catch you guys in the next video.